A simple clay jar could rewrite the history of human invention. Inside this unassuming pot, unearthed near Baghdad, lies a puzzle that has divided experts for generations. We are going to explore the artifact known as the Baghdad Battery. By the end of this journey, you will understand the full scope of a mystery that challenges the very timeline of technological progress. We will examine its strange construction and the fierce debate between those who see an ancient power source and those who see a common storage vessel. This investigation forces us to ask what truly defines a discovery and whether an object's purpose can be lost to time. What does it mean for our story if the spark of electricity was not a modern revelation, but a forgotten ancient secret? The year was 1936, or perhaps 1938, with records from the time offering two possible dates. On the sun-baked plains just outside Baghdad, a team of workers was leveling ground for a new railway line. Their shovels struck not earth but history, uncovering the foundations of an ancient village dating to the Parthian era, a civilization that flourished over 2,000 years ago. Archaeologists were called to the site, and amidst the routine cataloging of pottery and coins, one item stood out as utterly bizarre. It was a simple jar of yellow clay, roughly 13 centimeters tall, sealed with a plug of asphalt. To the untrained eye, it might have looked like a container for scrolls or spices, nothing more. But inside, the arrangement was anything but ordinary. The archaeologists carefully extracted a rolled sheet of copper, forming a cylinder, and within it, a solid iron rod. The asphalt plug had held both metals perfectly in place, keeping them separate from each other, yet suspended within the jar's interior. More curiously, the inside of the copper cylinder showed a distinct bluish corrosion, a telltale sign that it had once held an acidic liquid, perhaps something like vinegar or fermented grape juice. The object was logged, sketched, and stored away with a vague description. It was, for a time, just another curious relic in a museum basement, a puzzle without a question. No one digging in that Iraqi heat could have guessed that this unassuming pot would one day force us to reconsider a fundamental chapter in the story of human ingenuity. Its journey from obscurity to controversy was about to begin. The true mystery of this object only becomes clear when you take it apart. So let us do just that, piece by careful piece. Starting from the outside, we have the jar itself, a simple unglazed clay pot. It is not ornate or special in any way, exactly the kind of vessel you would expect to find from the Parthian era, which spanned from roughly 250 years before the Common Era to 250 years after. It is what is inside that transforms this ordinary container into an extraordinary puzzle. The first internal component is a cylinder, but it is not solid. It is made from a single sheet of copper, carefully rolled into a tube. The bottom of this copper cylinder is sealed with a disc, also made of copper, and the sealant used is a dark tar-like bitumen. Now inserted down through the center of that copper tube is an iron rod. This rod is held perfectly in place by a thick plug of that same bitumen which caps the top of the jar. This design is meticulously deliberate. The bitumen plug does two critical things. It seals the jar and it physically insulates the iron rod from the copper cylinder. The two metals are close, but they do not touch. This setup alone is curious, but the next clue is what truly ignites the debate. Inside the copper cylinder, researchers found distinct traces of a specific type of corrosion. This bluish-green residue is characteristic of an electrochemical reaction, the kind that happens when certain metals are exposed to an acidic liquid. Analyses have suggested the jar once contained something like vinegar or wine, a weak acidic solution that could serve as an electrolyte. So let us review the complete package. We have an outer ceramic vessel, an inner copper cylinder, a central iron rod, an insulating sealant keeping the metals apart, and evidence of a once present acidic fluid. Independently, each piece is mundane. Together they form a perfect, if rudimentary, model of a galvanic cell, the basic building block of a battery. It has two different metals acting as electrodes, a space for an electrolyte to facilitate a chemical reaction, and an insulator to prevent a short circuit. The physical evidence is sitting right there, quietly screaming its potential across two. The science behind this possibility is elegantly simple. At its heart, electricity is just the movement of tiny particles called electrons. A basic battery, known as a galvanic cell, creates this movement through a quiet chemical dance. You need two different metals, each with a different desire to hold on to its electrons. You also need a liquid bridge between them, an electrolyte, which is often something acidic like vinegar or lemon juice. When you connect this circuit, a natural reaction begins. One metal, called the anode, willingly gives up electrons. Those electrons then travel through an external path, creating a tiny current before being accepted by the other metal, the cathode. It is a fundamental transfer of energy, and it does not require any wires or advanced engineering, just the right materials in the right arrangement. If we place the Baghdad artifact into this scientific framework, the alignment is almost uncanny. The iron rod would act as the anode, the part that releases electrons. The surrounding copper cylinder would serve as the cathode, the part that collects them. The acidic fluid, long since evaporated but evidenced by that distinctive corrosion, was the essential electrolyte that completed the internal chemical loop. The bitumen plug was more than a simple seal. It was a perfect insulator, ensuring the two metals did not touch directly and short-circuit the whole delicate process. If you were to sketch a diagram of a primitive galvanic cell from a modern textbook, you would essentially be drawing this exact object. What would this ancient setup actually produce? The voltage would be very low, likely between 0.5 volt and 1.5 volts, depending on the exact acidity of the lost liquid. To put that in perspective, a single modern triple, a battery, provides about 1.5 volts. So one of these jars alone would generate only a faint whisper of power, not enough to light a bulb or drive a motor as we understand them today. But this is where we must step away from our modern expectations. What if the purpose was not for brute force, but for subtle sensation? A small, continuous current like this, perhaps from multiple jars linked together, could produce a mild but noticeable tingling sensation on the skin. It could also be used for electroplating, a process where a thin layer of metal, like gold or silver, is transferred onto the surface of an object using an electric current. This scientific plausibility is the bedrock of the entire mystery, proving that the concept was not beyond the materials and understanding of the time. The real question then shifts from could it work to a far more intriguing one. If it did work, what on earth was it? For that bitumen plug is not just ancient glue, it is the silent guardian of the entire hypothesis. To understand its importance, we need to look at it not as a single piece, but as a component engineered with two distinct critical functions. The first role is purely mechanical. This naturally occurring tar, abundant in the region, was the duct tape of the ancient world. Archaeologists have found it used everywhere, from waterproofing reed boats to sealing storage jars and mending pottery. Its adhesive and waterproof qualities were well known. In the context of our jar, it perfectly holds the iron rod suspended down the center of the copper cylinder, keeping it stable and in place. It also seals the top, which would be essential if the jar contained any liquid, preventing leaks and evaporation. So far, this fits a mundane storage purpose perfectly. But it is the second, more subtle function that sparks the controversy. Bitumen is an excellent electrical insulator. It does not conduct electricity. By encasing the top of the iron rod and forming a thick barrier between it and the copper cylinder's rim, the plug ensures the two metals cannot touch. If they did touch, they would create a direct connection, what we call a short circuit. This would instantly cancel out any potential electrochemical reaction, rendering the entire setup inert. In a simple storage jar, this careful, deliberate separation of metals serves no purpose at all. Why go to the trouble of suspending an iron rod inside a copper cylinder with such precision, only to fill it with scrolls or dried herbs? A wooden stopper or a simple clay lid would have been cheaper and easier. This meticulous insulation is only logically necessary if the intent was to keep the metals apart while still allowing them to interact chemically through a liquid medium. It is a detail that feels over-engineered for storage, yet perfectly engineered for function. This small, tar-like plug becomes a linchpin in the debate. For the skeptics, it is just evidence of good craftsmanship. For the proponents, it is the smoking gun, a clear sign that the ancient artisan was not just making a container, but a carefully balanced device where the conductive property of the sealant was as important as its ability to hold things together. The weight of the entire argument for an ancient battery rests in many ways on this unassuming lump of natural asphalt. Yet for every voice championing an ancient spark, another rises to argue for a far simpler flame. The mainstream view within archaeology offers a compelling counter-narrative, one that sees not a technological marvel, but a beautifully crafted container for something sacred. Most scholars look at the same components and assemble a completely different picture. The primary and most accepted theory is that this was a vessel designed to hold a precious scroll, perhaps a religious or ritual text. In this interpretation, the iron rod served as a sturdy core around which a sheet of parchment or papyrus could be rolled. The copper cylinder acted as a protective case, shielding the delicate document from moisture and physical damage. The bitumen plug was just that, a seal, keeping the contents safe and intact. This explanation aligns perfectly with other artifacts from the region, where scroll storage was a common and vital practice. It is a straightforward, elegant solution that requires no leap into unknown technological realms. Another school of thought suggests a use rooted in ritual or early chemistry, perhaps for electroplating sacred objects with a thin layer of gold, a practice known from other ancient cultures, though not definitively linked to this specific find. Or it could have held substances for ceremonial anointing. The core of the skeptical argument is not a lack of imagination, but a strict adherence to the evidence at hand. Archaeologists point out a glaring absence in the historical record. No wires have been found alongside these jars. No bulbs, no switches, no diagrams of circuits on temple walls. No contemporary text from the Parthian or later Sasanian periods describes anything resembling an electrical phenomenon or device. In a field built on context and corroboration, the Baghdad Battery stands in unsettling isolation. This skepticism is guided by a principle known as razor, a logical tool that suggests when faced with multiple explanations, the one requiring the fewest new assumptions is often correct. Here, the choice seems clear. One explanation uses only well-understood, documented practices of the era, scroll storage. The other introduces a complex, otherwise unverified technological concept, ancient electricity, for which no supporting infrastructure or description exists. From this vantage point, the battery hypothesis, while thrilling, asks us to believe in a solitary, silent revolution that left no other trace. It feels less like archaeology and more like a story we wish were true. But does the simplest explanation always capture the full complexity of the past? Or could it sometimes blind us to a quieter, more subtle truth waiting to be recognized? The jar itself holds a chemical whisper from the past. Forensic science has peered inside, past the clay and bitumen, to analyze the faint residues clinging to the metal. The findings are precise and telling. On the interior surfaces, especially around the iron rod, researchers have identified traces of acidic organic compounds. These are not random contaminants, but the chemical fingerprints of substances like vinegar, fermented grape juice, or perhaps citrus extract, all liquids that would have been readily available in that time and place. This is the proposed electrolyte, the crucial liquid bridge needed to complete an electrochemical cell. The corrosion on the iron tells a particular story. It is not the simple, uniform rust that comes from metal slowly aging in damp air. Instead, it shows a pattern consistent with galvanic corrosion, a specific type of deterioration that occurs when two dissimilar metals are connected through an acidic solution and an electric current flows between them. The iron, acting as the anode in such a system, would have been actively sacrificing itself, releasing electrons and ions into the solution. Meanwhile, the copper cylinder, potentially acting as the cathode, might display a different kind of patina, one less aggressive as it received those electrons. This differential corrosion, where one metal shows signs of active sacrifice and the other shows signs of protection, is a hallmark of a functioning galvanic couple. It is a tangible physical clue that something more dynamic than passive storage was happening inside that sealed space. For those who see a battery, this evidence is profoundly compelling. It moves the artifact from the realm of possibility into the realm of activity. We are no longer just looking at a collection of parts that could make electricity. We are looking at an object that shows the chemical scars of having done so, or at least of having been prepared to do so. The acidic residue is the bridge between an inert assembly and an intended device. It suggests someone did not just put these pieces together randomly. They filled the jar with a reactive liquid, sealed it, and initiated a quiet chemical process. This silent testimony from the metals themselves asks us a difficult question. If the goal was merely to protect a scroll, why choose a corrosive liquid that would damage the very document it was meant to preserve? The chemical clues lean heavily toward function, painting a picture of a jar that was not a quiet tomb for parchment, but a vessel for a gentle, ancient reaction. But who first dared to voice that electrifying possibility? The answer lies with a single individual, a man whose own story is as layered as the artifact he studied. Was a German archaeologist and curator at the National Museum of Iraq in the 1930s and 40s. He was immersed in the material culture of ancient Mesopotamia, surrounded by thousands of ordinary objects. Yet when he examined this particular clay jar with its iron rod and copper cylinder, he saw something no one else had. In 1940, amidst a world descending into conflict, published a quiet, revolutionary paper. He proposed that this was no scroll holder. He suggested it was a galvanic cell, an ancient battery, possibly used for the electroplating of gold onto silver objects. Imagine the intellectual courage that required to look at a simple pot in a museum basement and declare it a piece of forgotten technology was to challenge the entire established narrative of scientific progress. He was not just interpreting an artifact, he was proposing a hidden chapter in human history. At the time, his idea was met with profound skepticism, seen as fanciful and lacking evidence. It was marginalized, filed away as an odd curiosity, but had done something irreversible. He had planted a seed. He demonstrated that the story of an object is not fixed by its first description, but is fluid, shaped by the perspective of the observer. By asking a radical new question, what if this was for making electricity, he fundamentally redefined the artifact's potential narrative. His hypothesis, though dormant for decades, created a space for wonder. It invited future generations to look past the obvious and consider the whispers of lost knowledge. Because a storage jar would forever also be a battery in waiting, its true purpose suspended between two competing truths, each valid, each compelling, and each a testament to how one person's insight can illuminate a mystery for generations to come. Theories can swirl forever in the realm of ideas, but true understanding often demands getting your hands dirty. This is where experimental archaeology enters the story, transforming scholarly debate into tangible, measurable reality. In the 1970s, an American researcher named Gray decided to stop arguing about what the Baghdad artifact could be and instead discover what it could do. He built a precise replica using the exact materials, a clay jar, a copper cylinder, an iron rod, and a bitumen seal. For the electrolyte, he chose a substance the ancients would have had in abundance, fresh grape juice. When he connected his replica to a voltmeter, the needle moved. It registered a small but undeniable electrical current, around half a volt to 1 volt. The silent jar from the desert had, in a very real sense, spoken. Gray's experiment was a watershed moment. It proved conclusively that the object's design was not just accidentally electrochemical, it was functionally so. Anyone, using the technology of 2,000 years ago, could have generated electricity. This proof of concept opened the door to even more compelling demonstrations. Other researchers, inspired by Gray, began linking multiple replica jars together in series, creating a battery pack of sorts. With this increased voltage, they attempted one of the most speculated upon practical applications, electroplating. In a quiet laboratory, a modern version of an ancient workshop was recreated. A small silver object was connected to one terminal of the battery array, while a piece of gold was connected to the other. Both were submerged in a special gold salt solution. When the circuit was completed by the ancient-style batteries, a fascinating process began. Over hours, atoms of gold slowly left their source and journeyed through the solution, drawn by the gentle electric current, to deposit a thin, shimmering layer onto the waiting silver object. The result was not the thick, ornate plating of a modern factory, but a subtle, even gilding, exactly the kind of delicate finish seen on some ceremonial artifacts from the period. These experiments did something profound. They moved the mystery from the abstract into the concrete. We were no longer just looking at a strange pot and wondering, we were holding a working device and observing its effects. The artifact ceased to be a static museum piece and became a dynamic piece of technology with a demonstrable, albeit modest, purpose. This tangible evidence forces a difficult but exciting question. If modern hobbyists can achieve this with a simple replica, is it not reasonable to assume an ingenious artisan 2 ago could have discovered the same principle through observation and experiment? The gap between ancient mystery and modern understanding suddenly feels a little narrower, bridged not by speculation, but by the quiet hum of a recreated current. A working battery in isolation is a fascinating idea, but it is not a complete technology. This leads us to the most substantial and reasonable challenge to the entire theory, the deafening silence of the archaeological records surrounding it. If the Parthians or Sasanians were using electricity, even in a limited way, where is everything else? Where are the wires to connect the jars? Where are the primitive lamps, the tiny motors, the switches, or the tools designed to be powered by this current? In every other known ancient technology, from pottery wheels to aqueducts, we find a supporting ecosystem of tools, waste products, and complementary artifacts. With the Baghdad Battery, we find only the jar itself. Skeptics point to this absence as a fatal logical flaw. You cannot have a practical electrical system without a circuit, a complete loop for the current to flow and do work. A battery disconnected from anything is just a curious chemical reaction in a pot. The lack of any discovered conductors, like metal strips or wires from the same period and culture, is a glaring omission. There are no light bulbs, no electroplating workshops identified by unique residues, no diagrams on temple walls showing linked cells. From a strict archaeological standpoint, the artifact stands alone, an anomaly without a context, and in a discipline built on patterns and corroboration, that is a very difficult position to sustain. It suggests that either the technology was so ephemeral and specialized it left no other physical evidence, or more simply, that we have fundamentally misunderstood the object's primary use. Proponents of the electrical theory, however, offer thoughtful counterpoints to this silence. They suggest we may be looking for the wrong kind of evidence with modern eyes. Conductors need not have been metal wires, which might have been repurposed or corroded beyond recognition. They could have been something far more perishable, like threads or cords soaked in the same acidic electrolyte, creating a primitive conductive path that would have decayed entirely over centuries. The purpose itself might have been so subtle it left no obvious trace. Imagine a religious or healing ritual where the goal was not to light a room, but to produce a mysterious tingling sensation on the skin, a sacred shock to signify divine contact. Or consider a master jeweler using a few linked cells for delicate electroplating in a small, contained workshop. The evidence would be the faint, uniform gilding on a few special objects, not an industrial site. These uses would not require a sprawling electrical infrastructure. They would be quiet, specialized applications, the kind of knowledge possibly held by a small guild or temple priesthood, easily lost to time after a conquest or social upheaval. This debate leaves us with an incomplete and tantalizing technological picture. We have a device that demonstrably can function as a battery, yet we lack the surrounding story, the instruction manual, and the other characters in its narrative. Is the absence of wires proof it was never used, or is it merely a reminder of how fragile the full tapestry of ancient knowledge can be, with only the most durable threads surviving for us to find? Perhaps the most compelling application lies not in lighting a dark room, but in decorating a sacred object. The theory of electroplating, or more specifically, gold gilding, offers a tangible purpose that aligns with known ancient crafts. Imagine a skilled artisan wanting to coat a silver amulet or a small ceremonial figure with a thin, flawless layer of gold. Traditional methods existed, such as mercury gilding, where gold was dissolved in mercury and applied, a dangerous and toxic process requiring great skill. Another technique was foil gilding, physically hammering a thin sheet of gold onto the object, which could be uneven and wasteful. Now consider an alternative. If you immerse that silver object in a special solution containing dissolved gold salts, and then connect it to the negative terminal of a weak electrical source, something magical happens. Positively charged gold particles in the solution are gently drawn to the negatively charged object, bonding to it atom by atom. This is electroplating, and it results in an exceptionally even, adherent, and economical coating. The process is quiet, clean, and incredibly efficient, using minimal gold to achieve a stunning effect. We know such fine, uniform gold plating exists on artifacts from ancient Mesopotamia, pieces that display a mastery of surface decoration. The question becomes, could the Baghdad Battery have been the tool that made it possible? A single jar, producing perhaps 1 volt, would work, but it would be painfully slow, taking days to deposit a visible layer. The practical solution, however, is simple and elegant: link several cells together. Just as we bundle modern batteries to increase power, an ancient craftsman could have connected a series of these clay pots with simple metal strips or conductive cords. 5 or 6 jars linked in series could generate a noticeable few volts, enough to make the electroplating process feasible within a reasonable. This idea, however, requires a subtle but profound conceptual leap. It means someone did not just stumble upon a single curious jar that made their hand tingle. It implies a deeper understanding, a recognition that by combining multiple units, they could amplify an effect for a specific, repeatable purpose. This moves the artifact from a chance discovery into the realm of intentional technology, a tool for a specialized workshop. The existence of such finely plated objects does not prove the battery was used, as other methods were available. But it presents a fascinating parallel, a technological need that this forgotten device could have quietly, elegantly fulfilled, leaving behind only the beautiful golden proof and the silent, empty jars that might have made it. The world that created this object was a crossroads of empires and ideas. To truly weigh the possibility of an ancient battery, we must step into the bustling, sophisticated reality of the Parthian Empire, which held sway from roughly 247 years before the Common Era to 224 years after. This was not a dark age of stagnation, but a vibrant, cosmopolitan superpower. Stretching from the Euphrates to the Indus River, the Parthians were legendary and masterful traders, controlling the lucrative Silk Road and facilitating a constant flow of goods, cultures, and knowledge between Rome and China. Their wealth was immense, their cities opulent. Yet in our modern history books, they are rarely highlighted as pioneers of fundamental science. Their genius lay in synthesis, adaptation, and breathtaking practical engineering. We see this in their mastery of water, constructing intricate networks of underground canals called qanats to sustain agriculture in arid lands, a hydraulic marvel. Their artisans produced stunningly clear and colorful glassware. Their metalworkers crafted intricate jewelry, weapons, and ceremonial objects with a level of skill that still draws admiration. This was a society deeply fluent in the properties of materials, clay, copper, iron, and bitumen, and in manipulating chemistry through processes like fermentation and metallurgy. They operated from a foundation of sophisticated craftsmanship, not abstract theory. So where does the curious clay jar fit into this landscape? It does not stand as a glaring technological impossibility. Every single component was readily at hand in a Parthian workshop. The jar is ordinary pottery. The copper and iron were standard metals. The bitumen was a common sealant. The acidic electrolyte could be drawn from any kitchen. The innovation was not in the materials, but in their specific, purposeful assembly. This leads us to a profound question. Are we looking at an anomalous, one-off spark of genius, a forgotten experiment by a single curious mind? Or could it be a rare surviving fragment from a lost continuum of quiet, empirical tinkering? Parthian technological record shows a culture capable of complex problems solving through hands-on experimentation. The discovery of electroplating, or even just the tingling effect of a galvanic cell, would not require a university or a textbook. It could have emerged from the workshop floor, observed by a craftsman noting the strange interaction between different metals in a vinegar bath. This kind of knowledge, passed down orally within a guild or priestly class, is incredibly fragile. It leaves no philosophical treatise, only the occasional, puzzling artifact. Our modern definition of science often demands written formulas and published theories, but many ancient advancements were born from relentless, practical curiosity, a slow accumulation of what works without a formal explanation of why. The Baghdad Battery, in this light, challenges us to expand our view of innovation. It asks whether a society we do not typically associate with electrical science might have quietly nudged at the door of a fundamental force, using the tools they understood best, and left behind only a single, enigmatic key. Only a dozen or so of these peculiar jars have ever been recovered. This scarcity is a puzzle in itself, a quiet counterpoint to the grand claims of forgotten technology. If this was a common, widespread practice, why do we not find them by the hundred, stacked in storerooms like ancient pottery or tools? The limited number tells its own story, one that both skeptics and believers can interpret in different ways. For those who see a scroll case, the scarcity is unremarkable. It was a specific type of container, perhaps for important documents, and such items would not be produced in mass quantities. They would be made, used, stored, and eventually broken or lost, leaving only a handful to survive the centuries. But if we entertain the electrical hypothesis, this scarcity becomes far more intriguing. It suggests something not common but specialized. Imagine these objects not as household items, but as the precise tools of a temple priest or a master goldsmith. Their purpose would have been reserved for ritual or high craft, known to only a select few. Such knowledge, confined to a small circle, is incredibly fragile. When that guild dissolves or that temple falls, the understanding of what these jars did could vanish in a single generation. The objects themselves, now just odd pots, might be repurposed, melted down for their copper, or simply thrown away. Their components are the key to this idea. A clay jar is easily broken. An iron rod can be reforged into a nail or a blade. The copper cylinder is valuable and would be recycled. The very simplicity that makes the battery plausible also makes its remains archaeologically invisible. We must remember that survival is the exception, not the rule in the ancient world. Our view of the past is a gallery of fragments, not a complete catalog. Think of the legendary mechanism, that breathtakingly complex ancient Greek astronomical computer. Only one has ever been found, pulled from a shipwreck. Its existence implies a level of technical sophistication we never imagined was common, yet no other has surfaced. It stands as a solitary masterpiece, a glimpse of a knowledge that was nearly erased. The Baghdad batteries could represent a similar phenomenon, a lower-tech but equally significant spark of applied insight that flickered only briefly in a few workshops before the light went out. This scarcity forces us to hold two possibilities in tension. The first is practical, that these were simply uncommon storage vessels, and we have found roughly the number we should expect. The second is far more romantic, that we are looking at the scattered, broken pieces of a quiet revolution, most of its evidence recycled by time, leaving behind only these cryptic clues for us to decipher. The empty spaces between the artifacts are where the real mystery breathes, inviting us to wonder what else has been lost forever, and what secrets might still lie buried, waiting for a future shovel to strike not just earth but understanding. The gentle current from such a device would not just tingle, it might heal. This leads us into a more speculative, yet deeply human realm of possibility. Could these jars have served a medical or therapeutic purpose? While we lack any direct text linking the Baghdad artifact to medicine, we find intriguing parallels in how other ancient cultures interacted with electricity in the body. The Greeks and Romans wrote of using the torpedo fish, a species that delivers a powerful electric shock, to numb pain. Patients with gout or headaches would stand on these living generators in shallow water, seeking relief through the jolt. This was a clear, documented recognition that an external electrical force could alter bodily sensation. It was a crude form of electrotherapy, born from observation. If knowledge of the torpedo fish's effects could spread across the Mediterranean, is it so far-fetched to imagine a healer in Mesopotamia experimenting with a more controlled, gentler source of the same mysterious force? A single Baghdad battery produces a current far milder than an electric fish, but that could have been its advantage. Imagine a temple setting, where the line between healing and ritual was beautifully blurred. A priest, acting as both physician and spiritual guide, might have used the subtle current from one or two linked jars. The goal would not have been to violently shock, but to produce a sustained, buzzing sensation on the skin, perhaps applied to sore joints or temples. In a worldview where illness was often seen as an imbalance of unseen forces, the introduction of this tangible, yet invisible energy could have been profoundly symbolic. It might have been framed as channeling divine power, driving out malevolent spirits, or simply soothing afflicted tissue. The psychological and potential physiological effects could have been intertwined, offering comfort through both belief and genuine sensory intervention. This application is, we must stress, entirely conjectural. No ancient prescription has been found listing a clay pot, iron, and vinegar as a cure. Yet the idea resonates because it connects the artifact to a universal human pursuit, the alleviation of suffering. It places the battery not in a workshop, but in a space of care, suggesting its value may have been measured not in volts but in relief. This speculative journey reminds us that ancient innovation was rarely just about utility. It was often woven into the very fabric of how people understood their bodies, their spirits, and the mysterious forces that moved through both. This divide strikes at the very heart of how we interpret the past. Did a Parthian artisan carefully assemble the jar, rod, and bitumen with the explicit goal of generating a mysterious force? Or did they simply craft a durable scroll case, unknowingly creating a chemical arrangement that would baffle future generations? This is the core conflict between intentional design and serendipitous discovery. The object's perfect alignment with electrochemical principles feels too precise to be an accident, yet history is filled with breakthroughs born from happy accidents. The discovery of penicillin, for instance, came from a contaminated Petri dish, not a targeted search for antibiotics. Vulcanized rubber was stumbled upon when Charles accidentally dropped a mixture of rubber and sulfur onto a hot stove. Innovation often walks a winding path where chance observation meets a prepared, curious mind. So where does our jar fit on this spectrum? The meticulous insulation provided by the bitumen plug is the strongest evidence for intent. In a simple storage vessel, such careful separation of the metals is an unnecessary complication. It suggests the creator understood that keeping the iron and copper apart was functionally important, even if they explained that importance in terms of spiritual containment or material harmony rather than electrons and voltage. They may have known that it worked a certain way, without knowing why in our modern scientific sense. This leads us to a profound and humbling possibility. We may be projecting our 21st century framework onto an object born from a completely different worldview. The creator likely did not think in terms of electrical circuits or galvanic cells. They operated within a framework of material properties, sympathetic magic, alchemical principles, or ritual efficacy. The tingling sensation produced by the jar, if noticed, might have been interpreted as a manifestation of spiritual energy, a divine presence, or a proof of material purity. Our modern explanation, electricity, is simply the language we use to describe a physical phenomenon they experienced and perhaps harnessed under a different name. This does not diminish their achievement, it reframes it. It asks us to consider that ancient innovation could be both brilliantly deliberate and conceptually alien to us. The artisan may have been intentionally designing a device for a specific purpose, like gilding or ritual healing, guided by a set of cause and effect rules that modern science has since decoded with different vocabulary. The jar thus becomes a bridge between two ways of knowing. It challenges us to hold two truths at once, that a discovery can be both accidental in its underlying principle and intensely purposeful in its application. The silent vessel does not answer whether it was designed as a battery, but it powerfully asks us to expand our definition of what design even means across the vast gulf of time. The search for meaning does not stop at the borders of a single empire. To understand the Baghdad Battery's place in history, we must widen our gaze and look for echoes in other times and places. This journey reveals a fascinating pattern, not of identical devices, but of a recurring human curiosity about light, energy, and invisible forces. One of the most famous and hotly debated parallels comes from the temple walls of Egypt. Here, a series of stone reliefs carved over 2,000 years ago depict what some interpret as giant light bulbs. The images show priestly figures standing beside large, bulb-shaped objects with snaking filaments inside, connected by cables to what appears to be a power box. To a modern eye, the resemblance to electrical apparatus is startling. Mainstream Egyptology, however, offers a very different and well-supported interpretation. Scholars identify these scenes as symbolic representations of a religious myth, showing the creation of life through a lotus flower emerging from a primordial waters, with the so-called filaments being snakes, and the entire assembly a container for spiritual, not electrical, energy. The consensus is that this is profound religious iconography, not a technical diagram. Yet the persistence of the light bulb theory speaks to our deep desire to find lost technology, to see our own scientific reflections in the sacred art of the past. It highlights how easily we can project our modern frameworks onto ancient symbols, a cautionary tale for any interpreter of the past. A clearer, later parallel is the jar, invented in the 1740s. This was the first device capable of storing static electricity. Its design was elegantly simple, a glass jar coated inside and out with metal foil, with a metal rod passing through a conductive stopper to contact the inner coating. When charged, it could deliver a significant shock. The jar proves that early, functional electrical devices could be remarkably uncomplicated in their construction, not so different in principle from a clay pot with two different metals and an electrolyte. While no direct, identical twin to the Baghdad Battery has been unearthed in another culture, this broader search is illuminating in itself. It reveals a human tendency toward the independent discovery of natural phenomena. Different cultures in different eras have stumbled upon the strange properties of electric fish, static sparks, and certain chemical interactions. These were often isolated sparks of awareness, interpreted through the lens of magic or divinity, and rarely developed into a systematic technology. The question then shifts. Perhaps electricity was not a single, lost secret of one ancient civilization, but a subtle force whose whispers were occasionally heard in scattered workshops and temples across the world. These whispers never coalesced into the roar of an industrial revolution, because the social, economic, and philosophical conditions were not yet there to amplify them. The Baghdad Battery, whether a tool or a talisman, may be one of the clearest surviving echoes of that ancient whisper, a reminder that discovery is not always a straight line, but sometimes a faint, recurring signal, easily lost in the noise of centuries. The artifact's journey from museum shelf to modern myth is a story in itself. While archaeologists debate its purpose in scholarly journals, the Baghdad Battery has taken on a vibrant second life far beyond the walls of academia. It has become a star of documentaries, a central exhibit in countless books, and a favorite topic across the internet, where it fuels grand narratives of lost civilizations and forgotten wisdom. This cultural embrace reveals less about the object itself and more about our timeless fascination with hidden histories. The battery is a perfect catalyst for the imagination because it is not a vague legend. It is a real, physical thing you can see in a museum. Its scientific plausibility, that simple chemical reaction we can replicate today, gives these alternative theories a powerful anchor in reality. It becomes a tangible piece of evidence, a single puzzle piece that seems to suggest a much larger missing picture. From this one artifact, sprawling narratives are built. It is presented as proof of ancient electricity, which then becomes evidence for advanced prehistoric societies, perhaps even visitors from other worlds who shared their knowledge. These stories often carry a compelling theme of suppressed knowledge, the idea that mainstream science is ignoring or hiding a truth that challenges the established timeline. This is profoundly appealing. It turns the viewer into a detective uncovering a secret, placing them outside a perceived elite and into a community of truth seekers. The Baghdad Battery fits this role perfectly. It is enigmatic enough to allow for interpretation, yet concrete enough to feel like a genuine clue. Its transformation into a modern myth reflects a deep human desire, the longing to believe that our past is more mysterious and magnificent than textbooks allow, and that great truths still lie waiting just beneath the surface of accepted history. This cultural phenomenon asks us an important question. Are we drawn to the artifact for what it actually was, or for what it represents? The thrilling possibility that our story is far from complete, the raw materials tell a story of their own, a geographic fingerprint left on the artifact. That copper cylinder did not simply appear in a workshop. Copper mining was a major industry within the Parthian Empire, with significant sources in regions like the Anatolian Plateau and the mountains of modern-day Iran. The iron for the rod likely came from more localized sources, as iron smelting was a widespread and essential technology by this era. The bitumen, however, is the most telling clue. It almost certainly came from the vast natural seeps at Hit, on the banks of the Euphrates River, a source so famous it was mentioned by ancient historians like Herodotus. These materials did not exist in isolation. They traveled. The Parthians were masters of the Silk Road, their empire a sprawling network of caravan routes connecting workshops to mines and ports to markets. A lump of bitumen from Hit could travel east to a workshop in, where it might seal a jar containing copper from Anatolia and iron from the mountains. This convergence of traded materials suggests the artifact was not a casual, improvised object made from whatever was lying around. It was a deliberate assembly of specific components, each chosen for its known properties. The craftsmanship confirms this intention. The copper sheet is rolled with a consistent, precise diameter. The iron rod is straight and finished. The bitumen plug is not a crude glob, but a fitted seal, carefully applied to insulate and hold the metals in perfect alignment. This level of precision points away from a common potter making storage jars and toward a specialist, perhaps a metallurgist or a craftsman familiar with working multiple materials. Such an artisan would understand the behavior of copper versus iron, the sealing quality of bitumen, and the importance of a tight fit. The time and skill invested matter. If this was just a scroll case, a simple clay tube with a wooden stopper would have been infinitely cheaper and faster to produce. The decision to use more valuable traded metals and to execute such careful joinery implies the object was meant for something more than passive storage. It was built to perform a function, to contain a process, whether chemical or sacred. The sourcing and craftsmanship quietly argue that this was no ordinary pot. It was a valued tool, assembled with purpose by someone who knew exactly what they were doing, even if we are still deciphering the language of their intentions. This entire debate is in how science grapples with history. At its core, the mystery of the Baghdad Battery is not just about an object, but about a process, the scientific method itself applied to the silent past. It begins with a clear observation, the artifact and its specific, curious construction. From that observation, a bold hypothesis is formed. This was an ancient galvanic cell designed to generate electricity. A good hypothesis must make testable predictions, and here they are clear. If the hypothesis is correct, then a replica should produce a measurable electric current. Furthermore, if multiple cells are linked, they should be capable of electroplating metal. These predictions lead directly to experimentation. Researchers like Gray built those replicas, filled them with grape juice and connected the voltmeter. The needle moved. Others linked jars and successfully plated gold onto silver. The experiments confirmed the predictions, lending significant credibility to the hypothesis. This is the clean, logical beauty of the scientific method in action. Yet, archaeology exists in a uniquely challenging space. While we can test what the object could do, we can never definitively prove what it was for. We cannot interview the artisan. We cannot find their workshop notes. We cannot observe the object in use. The original creator's intent is locked away, forever beyond the reach of our experiments. This is the fundamental difference between a laboratory science and a historical one. In a lab, you can control variables and repeat trials to exhaustion. In the field, you have only the fragments that survived, a puzzle with most of its pieces missing. The evidence is inherently incomplete, and therefore always open to interpretation. The same set of facts, the jar, the metals, the corrosion, can support multiple plausible narratives, from sacred scroll case to primitive battery. Our conclusion is not dictated solely by the data, but is also shaped by the questions we choose to ask and, inevitably, by the biases we bring to the table. Do we prioritize razor and favor the simplest explanation? Or do we allow for the possibility of lost complexity and quiet innovation? The answer often depends on whether one views history as a steady, linear progression or a story punctuated by forgotten flashes of brilliance. This uncertainty is not a failure, but a profound lesson in humility. The Baghdad Battery teaches us that our understanding of the past is always provisional, a best guess based on the evidence at hand. It reminds us that history is not a set of fixed facts waiting to be memorized, but an ongoing conversation, a dialogue between the present and the fragments of the past. Each generation brings new tools, new perspectives, and new questions to these ancient riddles. What we see in that clay jar today is filtered through our own world of electricity and technology, just as an interpreter from a different culture might have seen a vessel for spirits or a container for celestial energy. The artifact itself remains unchanged, but its story evolves with us. This makes the Baghdad Battery far more than a curious relic. It becomes a perfect case study in historical epistemology, a deep inquiry into how we know what we think we know about times long gone. It invites us to hold our conclusions lightly, to embrace the mystery, and to remain forever curious, for the final chapter of this 2,000-year-old story has yet to be written. A mild tingle on the skin could be a message from the heavens. To truly grasp the artifact's potential, we must step into a mindset where the boundary between the physical and the spiritual was porous and alive. For the ancients, the world was animated by unseen forces. A lightning bolt was not a discharge of atmospheric electricity, it was the weapon of a storm god. The strange attraction of rubbed amber for bits of straw was not static charge, but evidence of a living spirit within the material. In such a world, a device that generated its own subtle, invisible force would not be seen as a tool, but as a conduit. The gentle current from the jar, perhaps felt during a temple ceremony, could have been interpreted as the literal touch of the divine, a sacred vibration confirming the presence of a god. This reframes the object completely, not as a primitive battery, but as a ritual instrument. Imagine a darkened inner sanctum. A high priest, the only one who understands the secret of the sacred jars, prepares for a ceremony. Before a statue of a deity, he connects several of the vessels with cords. He might place 2 metal terminals in a basin of water or have an initiate hold them. When the circuit is completed, a collective gasp rips through the room as the idol seems to hum with energy, or the water subtly bubbles, or the initiate feels a mysterious warmth and vibration in their hands. This is not a parlor trick, but a profound theological experience. The device makes the intangible tangible. It provides a physical sensation to anchor faith, a shared experience that binds the community to the divine narrative. In this light, the bitumen plug is not just an insulator, it is a seal containing sacred power. The copper and iron are not electrodes, but symbolic metals, perhaps representing the sun and the earth, brought into a harmonious, active relationship. The acidic fluid is not an electrolyte, but a potent elixir, chosen for its ritual purity. The object's purpose shifts from the utilitarian to the transcendental. Its value lies not in what it does in a mechanical sense, but in what it means and what it makes people feel. This interpretation liberates the artifact from our modern obsession with function and places it where it likely belonged, within a rich tapestry of symbol, ceremony, and the human yearning to interact directly with the mysteries of the cosmos. The true power of the Baghdad Battery in this view was never measured in volts but in wonder. The timeline of this object is itself a shifting puzzle. While most sources confidently place the Baghdad Battery within the Parthian era, roughly 250 years before the Common Era to 250 years after, this date is far from certain. Some experts who have studied the excavation notes and the jar's form have suggested it could belong to the later Sasanian Empire, which rose in 224 and lasted until the mid-7th century. A difference of a few hundred years might seem minor against the backdrop of, but in archaeology, context is everything. Shifting the artifact from the Parthian to the Sasanian period moves it into a different world of empires, technological priorities, and cultural practices. This uncertainty stems from the primary methods used to date such finds. The first is stratigraphy, analyzing the layer of earth in which the object was found. If the layer contained coins or pottery of a known age, it could anchor the artifact to that period. The second method is stylistic analysis, comparing the shape, clay composition, and craftsmanship of the jar to other, better-dated pottery. Both methods require interpretation and can be influenced by incomplete records or the mixing of soil layers over centuries. The result is not a digital timestamp, but a range of plausible centuries. This inherent fuzziness in the historical record is not a flaw, but a fundamental characteristic of archaeology. It is a science of best guesses, built from fragments and patterns. For the Baghdad Battery, this chronological ambiguity becomes a powerful narrative tool. A proponent of the electrical theory might favor a Sasanian date, pointing to that empire's renowned advances in metallurgy and engineering as a more fertile ground for such experimentation. A skeptic might anchor it firmly in the Parthian period, emphasizing the well-documented use of scroll cases at that time. The artifact's elusive birthday allows it to slip between the cracks of history, fitting whichever context strengthens a particular argument. This reminds us that the stories we tell about the past are often shaped by the questions we ask in the present, and sometimes the evidence is quiet enough to let more than one story be told. This classification gives the artifact a powerful name, an or out-of-place artifact. That single word unlocks a deep psychological fascination far beyond archaeology, and does not simply sit in a display case, it acts as a splinter in the smooth timeline of history we are taught. Our standard narrative is one of linear, cumulative progress, a slow march from stone tools to silicon chips. An object like the Baghdad Battery disrupts that clean story. It whispers of potential leaps, forgotten regressions, or even influences we have not yet considered. It introduces a thrilling element of chaos into the ordered past, suggesting our ancestors might have been far more curious, more capable, or more connected than we ever dared to assume. This disruption satisfies a fundamental human craving, the desire for mystery itself. It is the allure of the hidden chapter, the lost blueprint, the secret that changes everything. A textbook can feel final and settled, but it is an open question made of clay and copper. It invites us to become detectives, to participate in the story, to look at the familiar sweep of history and wonder what vital pieces are missing from the puzzle. This is why dry academic skepticism, while vital, often struggles against the powerful tide of wonder. The facts of the scroll case theory are logical, but they are also complete. They close the book. The battery theory, however, opens a door. It leads to a corridor of what-ifs, a space where imagination and history dance together. And of all the ancient mysteries, why does the idea of electricity hold such particular power? Because it touches the very force that defines our modern existence. Electricity is the invisible bloodstream of our civilization, the pulse behind our light, our communication, our very understanding of the universe. To think that a whisper of this fundamental force might have been known 2,000 years ago is not just a historical curiosity, it is a profound philosophical jolt. It suggests a different kind of connection across the ages, not just of culture or art, but of grappling with the same elemental truths of the physical world. The Baghdad Battery endures not because it is the strongest archaeological evidence, but because it is the perfect symbol. It represents the exhilarating possibility that we have underestimated the quiet genius of those who came before, and that the story of human ingenuity is wilder, more mysterious, and far more interesting than we have been led to believe. Our modern categories of science and magic did not exist for the minds that shaped this object. They operated within a world of transformation, where matter held hidden potentials waiting to be unlocked. This was the domain of alchemy, a profound tradition that wove together spiritual pursuit and hands-on experimentation. In this light, the Baghdad Battery's components tell a different story. Copper and iron were not mere conductors, they were symbolic metals, each associated with celestial bodies and spiritual principles. The acidic fluid was not just an electrolyte, but a potent aqua or transformative elixir. The entire assembly could be seen as a sealed vessel for change, a crucible for observing how substances interact and evolve when brought into deliberate, controlled contact. An alchemist might have built this device not to generate a current, but to witness a process, to see if the iron would be transmuted or if a new spirit would emerge from the reaction. This was a form of early chemistry, a patient, empirical probing of nature's secrets. The goal was understanding the hidden properties of materials, a quest to grasp the fundamental forces that animate the physical world. From this perspective, the tingling sensation of a galvanic current, if noticed, would have been a thrilling discovery, a physical manifestation of the invisible life force they believed flowed through all things. It would have been proof of concept, not for a battery, but for a philosophical idea, the tangible presence of a transformative energy. This interpretation elegantly bridges the ritualistic and the practical. The artifact becomes a tool for exploration, a physical question posed to the universe. Its creators were not electrical engineers, but natural philosophers and meticulous craftsmen. They were documenting cause and effect, building a body of practical knowledge about how the world worked, one careful experiment at a time. Their framework for explaining why it worked involved spirits, sympathies, and celestial influences, concepts alien to our textbooks. But their meticulous record of what happened, captured in the very design of this jar, demonstrates a rigorous observational intelligence. They were mapping the territory of material reality with the only compass they had, a blend of reverence, curiosity, and skilled hands. The Baghdad Battery, then, may be a relic from the very dawn of the experimental method, a silent witness to the moment when humanity began systematically asking the material world to reveal its secrets. Standing in a museum display case, the artifact's identity is decided by a small printed label. At the National Museum of Iraq in Baghdad, the object is often presented under a cautious title, something like Parthian clay jar with copper and iron components. The description that follows might detail its construction and the scroll storage theory, perhaps adding a single line acknowledging an alternative hypothesis about electricity. This is not an attempt to hide a secret, but a reflection of institutional responsibility. Museums are custodians of history, and their primary duty is to present information backed by the strongest consensus within their field. To label it definitively as the ancient battery would be, from a scholarly perspective, to overstep the evidence. They present the known context first, the world of Parthian storage and ritual, leaving the speculative spark as a footnote for the curious visitor to pursue. This curatorial choice is powerful. For a family on a weekend visit, the object becomes a beautifully made ancient vase, a snapshot of daily life 2,000 years ago. The deeper mystery remains tucked away, visible only to those who already know to look for it. In other institutions or traveling exhibits, the balance might shift. Some displays place the battery hypothesis front and center, using replicas and interactive diagrams to show how it could have worked. Here, the artifact transforms from a relic into a question, an invitation to wonder. The label becomes a starting point for debate rather than a final statement. This difference in presentation is not about right or wrong, but about narrative control. The museum, as an authoritative institution, gently guides the public's first impression. It decides whether the object is primarily an answer or a question, a closed chapter or an open book. By choosing which story to highlight, these cultural gatekeepers shape our collective imagination about what the past contained. They validate certain lines of inquiry while leaving others in the margins, demonstrating that the telling of history is never a neutral act. It is a continuous process of selection and emphasis, where every displayed object carries not just the weight of its own age, but the weight of our modern interpretations. The artifact's quiet life under museum lights is therefore a crucial chapter in its biography, a testament to the ongoing conversation between the cautious guardians of the past and the boundless curiosity of those who gaze upon it. The linear timeline of progress is a story we tell ourselves for comfort. We see history as a staircase, each step building firmly upon the last, leading inevitably upward from the stone axe to the smartphone. But the silent challenge posed by the Baghdad Battery is that it suggests a different shape entirely, a spiral perhaps, where ideas surface, vanish into the cultural soil, and may rise again centuries later in a different form. This artifact invites us to consider that technological advancement is not a straight, cumulative line, but a fragile, flickering flame, easily extinguished by the winds of social change, economic need, or simply the passage of time. Across the ancient world, we find these brilliant sparks that never ignited a wider fire. The most famous companion to our clay jar is the Greek, a sophisticated steam engine built by Hero of Alexandria in the 1st century. It was a marvel of engineering, a spinning sphere propelled by jets of steam. Yet for the Greeks, it remained a temple wonder, a philosophical demonstration, or a curious toy. They never connected it to pumps, mills, or ships. The necessary ingredients for an industrial revolution were all present: advanced metalworking, scientific curiosity, even slavery as a labor force. But the social imagination to see steam as anything other than a spectacle was absent. The economic pressure to mechanize on a massive scale simply did not exist in the same way it would in 18th century Britain. This is the powerful concept of path dependence. A society does not invent in a vacuum. It innovates along the paths laid down by its immediate needs, available materials, and deepest cultural beliefs. The Parthians were master traders and cavalry-based warriors. Their genius flowed into superb logistics, hydraulic engineering for desert agriculture, and exquisite metalwork for status and ritual. A gentle electrical current, while fascinating, might have found a narrow, sacred niche within this framework, a tool for gilding precious objects or creating awe in a temple. There was no grid to build, no motors to drive, no economic or social imperative to scale this whisper of a discovery into a shout. So the more profound question shifts. It is no longer simply, did they have electricity? The replicas prove they could have. The deeper, more haunting question is, why didn't they do more with it? The answer likely lies in the ecosystem of innovation. A seed cannot grow without the right soil, water, and sunlight. The seed of electrical knowledge may have been present, but the soil of industrial demand was not. The water of a scientific method focused on practical application was scarce. The sunlight of a philosophical framework that saw nature as a machine to be mastered rather than a spirit to be revered was still over the horizon. This cyclical view of knowledge is both humbling and liberating. It means our modern technological dominance is not an inevitable destiny, but a specific contingent outcome. It suggests that brilliance is a constant in human history, but its trajectory is shaped by 1,000 invisible forces, from trade routes to religious dogma to the simple cost of copper. The story of the Baghdad Battery, then, is not a tale of a failed invention. It is a reminder that every era holds discoveries whose full potential remains dormant, waiting for a future world with different dreams and different needs to wake them. That simple clay jar, resting silently behind glass, has never needed to be solved to be important. The Baghdad Battery remains an open circuit in the story of human ingenuity, a puzzle where every answer seems to generate two new questions. We have journeyed from its dusty discovery on a railway embankment to the quiet hum of modern laboratories, through the halls of skeptical academia and the boundless landscape of popular imagination. We have examined the meticulous craftsmanship, the chemical whispers, and the deafening silence of missing wires. The core debate may never reach a final verdict. Was it a primitive power source, a sacred scroll case, or a ritual instrument for channeling divine force? Each interpretation is a lens, and through each we see a different facet of the ancient mind. Yet perhaps its ultimate purpose is not the point. The artifact's true, enduring power lies in its stubborn refusal to fit neatly into our timeline. It actively challenges the comfortable, linear narrative of progress we so often cling to. This object insists that history is not a closed book of settled facts, but a living, breathing conversation across the centuries. It is a dialogue between the artisan who sealed the bitumen and the scientist who measured the voltage, between the curator who writes the museum label and the viewer who stands before it, wondering. In this ongoing exchange, sometimes the most humble and unassuming artifacts speak the loudest. They remind us that the past is not a foreign country, but a series of rooms in a vast shared house, and we are still finding doors we never knew were there. Let this particular mystery serve as an invitation. Let it inspire you to look at the ancient world not as a completed lesson, but as a landscape rich with quiet enigmas. Question the narratives handed down to you. Embrace the gaps in the record, for that is where curiosity lives. And remember, the next chapter of this 2,000-year-old story is being written by everyone who chooses to look, to wonder, and to ask, what if?